All right, guys, so we're going to practice. I've got a list of compounds. The first 5, I have the formula, and we need to write the names. And then the next 5, I have the names. We need to write the formula. You got to be able to go back and forth either way. Be pretty quick about it. The key here, like normally, I teach this stuff in class. I work some examples, and then I tell everybody, okay, next class we have a quiz over naming. Everybody comes in and they think they got it down because it seems like a pretty easy concept. But then when they start doing it, the class average usually ends up being like a 30 on that quiz. Because everybody thinks they know it, but they really don't. Until you really practice it, the details will eat you up. So let's go through this carefully. Actually, do it yourself real quick right now, and then I'll go through them and see how you do. And if it's not exactly correct, it's wrong. Okay? Naming compounds, writing formula, there is no leeway. You got to have it perfect. Okay? So do that now, and then restart the video. All right, the first one, I can look at that and say for PbO2, I know that there's lead. I know that oxygen's going to be oxide. But essentially, every time I name one of these, I need to be thinking in my head, do I have a covalent compound? Do I have a what I call a simple ionic compound? And what I mean by that, simple ionic means it has a metal whose charge is always the same. Group 1 metals are always +1, group 2 metals are always +2. The 3 that we learned in the diagonal box always are the same, +1, 2, and 3. For those, I know what the charges are. Everything's easy. I don't need a Roman numeral. And then finally, do I have ionic with a transition metal? Okay? Now, for each one of these, the rules are a little different. For the covalent, I'm going to use prefixes. For simple ionic, I don't have to do anything extra. And for ionic with transition metal, I need Roman numerals. And by the way, Roman numerals, you really need to know 1 through 7. So 1 is I, 2 is II, 3 is III, 4 is IV, 5 is V, 6 is VI, 7 is VII. Okay? So every time I name a compound, I need to know which category I'm dealing with. So for this one, lead's a metal, oxygen's a non-metal, so I know it's ionic. If you look at where lead is on the periodic table, it's a transition metal, and that tells me when I finish naming, I ought to have a Roman numeral in there. The Roman numeral represents the charge of the metal. So looking at this, I say, okay, lead and oxygen, I got that part right. So now I need to look at the formula. Can I figure out what lead's charge is? I know that oxygen is always -2, but there are 2 of them. So it's 2 oxygens that both have -2 charges, and then I only have 1 lead. Ionic compounds are neutral, so I know these negative charges have to be canceled out by whatever lead's charge is. I have -4 here, so that has to be a +4. So I should write lead 4 oxide. That's the correct name that we should have come up with. Next one. I got calcium. And then Cn. Now again, I can tell which students have learned their polyatomic ions because sometimes students will look at this and they'll make something up. They'll be like calcium, carbon, nitride, whatever, and they'll have too many things. Whenever we name compounds, there should only be 2 parts. There's whatever comes first and whatever comes second. And if you're naming more than 2 things, that probably means that you're not recognizing a polyatomic ion. Okay? So Cn is cyanide. So calcium with cyanide. Now, do I use prefixes? Am I done? Or do I need Roman numerals? I got to think about it. Well, calcium's a metal, cyanide's a non-metal ion, so this is going to be an ionic compound, and calcium's in group 2. I know for group 2, calcium is always going to be +2. So Roman numerals aren't needed. I'm in this category where basically calcium cyanide, that's it. I'm done with that one, that's the name. If you put calcium dicyanide, you're wrong. If you put calcium Roman numeral 2 cyanide, you're wrong. You got to do it exactly the right way. All right, SiS2. So first one is silicon. Second one is sulfur becomes sulfide. And then I look at it, so silicon is a metalloid, sulfur is a nonmetal. If I put a metalloid with a nonmetal, that's actually considered covalent because they're pretty close to each other. So they're going to behave similarly. So if it's covalent, that means I need prefixes. So in front of the first one, I would need mono, except the rule is you don't have to put mono on the first element. Okay, to remember that, just think about CO2. We don't call that monocarbon dioxide. We drop the mono and just say, oh, it's a carbon with 2 oxygens, right? So when you're starting with one of something, you can just leave it as it is. So it's 1 silicon with 2 sulfurs. So I'm going to put disulfide. Silicon disulfide. All right, next one. I know I've got sodium. And then CO3 is carbonate. Actually, that ought to be a subscript. Sorry about that. Sodium and then CO3 is carbonate. This is a metal and a polyatomic ion, so I'm definitely ionic. Sodium is a group 1 metal, so I always know its charge, which means I'm done. Sodium carbonate is the name. Next one, Ag is silver. ClO4 is perchlorate. Okay, so silver is a metal, perchlorate is a nonmetal ion, so I'm definitely in the ionic section. Now silver is a transition metal, so I think, oh, I might need a Roman numeral, but then you got to remember, oh wait, silver was one of the ones in the diagonal box. I know that silver is always +1. I can even double check it here. If silver is +1, perchlorate is -1, that makes sense, right? I mean, +1, -1, that's the right formula. So I don't need to know the Roman numeral for silver because everybody's supposed to know it's +1. So basically that's it. Don't put a Roman numeral with silver or zinc or aluminum. All right, next one. So now I'm to the ones I have the name, I got to write the formula. So lithium is Li. Phosphate is PO4, but these are both charged, so this is going to be an ionic compound. If I'm doing an ionic compound, I need to think about the charges. Lithium is a group 1 metal, its charge is +1. Phosphate is a polyatomic ion you're supposed to memorize, it's 3-. And at that point, if I just swap them, I'd get Li3PO4. Okay? Now, a lot of times I see students that like, you'll see in some of these, they're going to have parentheses around a polyatomic ion. You only do that if you have more than one of the polyatomic ion. Like here, PO4, sometimes people think that means there's 4 phosphates. It's not right. Phosphate is all that together, that's 1 phosphate. If I need 2 phosphates, that's when I put parentheses around it and put a 2 on the outside. Okay? So don't use parentheses on polyatomic ions unless you have more than one of that polyatomic ion. Example, right here, cyanide is Cn, has a -1 charge. The parentheses and the 2 outside means I have 2 cyanide ions. All right, next one. Copper, Roman numeral 1, that tells me the charge is +1. Acetate, CH3, COO minus. Now, I will say acetate's a weird one. There are several different ways it can be written. Sometimes you'll see them combine the two oxygens and it'll be CH3, CO2 minus. That's fine. Sometimes they'll combine everything and have like C2, H3, O2 minus. Those are all okay for 1211. But as we move on into 1212 and especially organic chemistry, the first one actually gives me a little bit more information about how the atoms are connected. The first carbon has 3 hydrogens connected to it, and then it's connected to the second carbon, which has the oxygens connected to it. Like, this one is a little bit more informative about the structure of the molecule. So this is preferred over the other two, but honestly, I'll accept any of them for this semester. Okay? But let's just go with the first one for now. When I put them together, the charges have to cancel, because again, this is ionic. But if it's +1, -1, they're good. I just put them together and I'm done. So the formula ought to be Cu, CH3, COO. That's copper 1 acetate. All right, next one, aluminum sulfate. So Al, I know aluminum is supposed to be +3 because it's one of the ones we're supposed to know. Sulfate, SO4, has a 2 negative charge. So now when I put them together, the 3 on aluminum is going to come down on sulfate, the 2 on sulfate is going to go down on aluminum, so it's going to end up being Al2, SO4. Now sulfate, that's sulfate. If I want to multiply by 3, I got to use parentheses. It's 3 of everything inside. Okay, now, there are going to be questions, especially when you get into chapter 3, where it'll ask like, okay, in this formula, how many sulfurs are there? And the answer is, sulfate has 1 sulfur in it, but there are 3 sulfates. So whatever, there's a 1 here, 1 times 3, that means there's 3 sulfurs in that formula. How many oxygens are there? Well, each sulfate has 4, but there's 3 sulfates. So 4 times 3, there are 12 oxygens in that formula. So this compound, 1 formula unit of this compound, would have 2 aluminums, 3 sulfurs, and 12 oxygens. Again, that's beyond where we are right now, but it's coming soon. All right. Finally, dihydrogen monoxide. So if you see prefixes, di and mono, that means it's going to be a covalent compound. Don't even think about charges at all. Covalent compounds are sharing electrons. It's a whole different ballgame. But dihydrogen monoxide, well, dihydrogen means H2. Monoxide just means 1 oxygen. That's H2O. So that's the chemical name of water, dihydrogen monoxide. All right, last one, iron 3 chlorite. So iron is Fe, 3 is the charge, and then chlorite is ClO2 minus. So when I put them together, the 3 comes down here, the 1 comes down there, so I end up with Fe, ClO2 with a 3 outside. I would read that as Fe, ClO2 3 times. Anyway, so that's it. We'll cut it off there.